right, so I want to talk you guys through some explanations of impulse demos. We'll do the demos in class. One that you have likely seen someone attempt before, maybe on YouTube, or maybe we already did it in class, is pulling out the tablecloth from underneath some dishes. Okay, so let's try to use our understanding of momentum and impulse to think this through. So let's first think about the bad situation, which physics terms it isn't bad, it's just not super interesting, right? If I provide a very small force for a great time duration, what's gonna happen? Well, everything's gonna move, right? I'm applying the force onto the tablecloth. How does the plate and the cup begin to move? There's friction here and here. And so if I provide a small force for a lot of time, this small force and this small force and this small force are sufficient to continue pulling on everything. And all that time means that even though you pulled slowly, you're able to get it moving very fast eventually. All right? Now, that would be a kind of sad situation because all of your dishes would fall on the ground. But it helps us understand the opposite of when we try to use a very big force on the tablecloth and we do it for a very short amount of time. Now, our force that's big is still only on the tablecloth. And friction is still going to be small because friction is limited by some of those factors from previous units, right? Mu times Fn. We could calculate how big friction is, but it has a limit. Now, our force, we choose to do it really fast, so beyond the limit of that friction. Now, because I'm providing a force really big, very quickly, I am able to get the tablecloth up to speed very quickly. I'm going to give it a lot of momentum. But the cup and the plate, which currently have a momentum of 0, would need to be also experiencing a force for amount of time in order to get moving. And they will experience a small force from the friction. They will. But they'll experience it for such a small time that the amount of momentum that they gain is they have a small gain in momentum, but the tablecloth has a large gain in momentum. The other way to get this to work really well is you pick, well, all tablecloths are pretty low mass, right? So we've already established that the tablecloth is going to experience a large gain, and the plate and the cup are going to experience a small gain. But the way to make it visually more exciting is how do we make it move the least? Well, it's going to gain a small amount of momentum. But if we choose to shift all of those momentums gained in terms of mass, if we make this a really heavy plate, and maybe we make the cup out of crystal, which has lead in it, and as you experienced in class, lead is super heavy. If I have very large mass, when I gain a small amount of momentum, I'm going to have a huge mass, which means I'm going to have an itty bitty little amount of velocity gained. So a small change in velocity. And here, I'm going to gain a lot of momentum. But if I choose to do the opposite and only do a small amount of mass for the tablecloth, right? Maybe I cut back and maybe I trim up the tablecloth so it's shorter. Small amount of mass. When I gain a lot of momentum, the result is going to be that I gain a lot of velocity. And so the tablecloth moves away quickly, and the plates and the cups stay almost right where they were. Now again, we see that they move a little bit, but not very much. All right. There's going to be a lot of demos that cover this same idea. Your job is to practice extending this knowledge to new situations. All right.